Okay, so have you ever heard of water, like, actually burning?
Burning water.
Yeah, like flames shooting out of a lake.
I mean, water puts out fires, right?
Exactly.
Yeah.
It's like the opposite of what we expect. And then there are those stories about eerie glowing lights in the swamps that people have, told for centuries.
Yeah, the whole ghost lights thing, right? I've heard about those spooky stuff.
Definitely spooky. And then to top it off, there are these explosions, massive explosions that can, like, wipe out entire city ports.
Okay, now that sounds straight out of a disaster movie. What is going on here?
Well, for you, today we're diving deep into the really wild world of two elements, phosphorus and nitrogen. These seemingly ordinary elements are behind these bizarre phenomena and a lot more.
Oh, wow. I am intrigued already. I mean, I know phosphorus is in like matches and stuff, but explosions.
It's more than just matches, believe me. We're going to uncover how these elements, with their unusual chemical behaviors, have sparked myths, fueled folklore, and even caused some of history's biggest disasters.
So we're talking about real world magic almost. I'm in. Let's do this deep dive.
Exactly. We've got a ton of historical accounts and, some cutting-edge scientific explanations to unpack. So get ready to have your mind blown because we're about to reveal the chemistry behind these seemingly magical events. It's all about turning the myths and legends into, like, real understanding.
I'm all about myth busting with science. Let's get started.
Okay, so first up, phosphorus. This element has some truly weird and wonderful properties. I mean, even its discovery story is crazy. Back in 1669, there was this alchemist named Hennig Brand. Those guys who were obsessed with turning lead into gold.
Yeah, the classic alchemist dream. So what was he trying to make gold out of phosphorus?
He was actually trying to make gold from something else entirely, urine.
Wait, urine? Okay, now that's just weird.
It is. I mean, the whole idea is pretty out there.
Yeah.
But Brand was convinced he could isolate gold from, human waste. So he boiled down huge amounts of urine.
I can only imagine the smell.
Oh, I'm sure it was awful. But instead of gold, he ended up with this white, waxy substance that glowed in the dark and, here's the kicker, burst into flames when exposed to air.
Spontaneous combustion, that's not something you see every day.
Definitely not. And this wasn't just any flammable substance. This was white phosphorus. And it's so reactive that it'll burn even underwater, as long as there's like a little bit of oxygen around.
Wow, underwater fire. That's just mind-boggling. No wonder people were so freaked out by this stuff.
Oh, absolutely. Imagine encountering water that could catch fire. We actually have historical accounts of this happening in India and Europe.
So people were literally seeing water go up in flames. How did they explain that back then?
Well, they didn't have the scientific knowledge we have today, so their explanations were, a bit more supernatural. They thought it was like a curse or some kind of divine intervention.
Makes sense, right? I mean, how else would you explain burning water if you didn't know about phosphorus?
Exactly. And these weren't just like small incidents either. We've got accounts from 19th century Bengal of entire lakes that would glow at night, with actual flames rising from the water. For the locals, it was obviously a supernatural event.
Oh, a glowing, fiery lake. I can see how that would spark some wild stories.
Oh, absolutely. But we now know that these events were probably caused by phosphorus runoff, likely from industries polluting the water. When the water was disturbed, the phosphorus would react with the air, creating those eerie light shows.
Ah, so pollution causing a spooky spectacle. It's like a reminder that even the seemingly magical often has a scientific explanation lurking beneath the surface.
Exactly. And it shows how a lack of scientific understanding can lead to, all sorts of myths and superstitions. But phosphorus isn't all glowing lakes and spooky stories. This element has a really dark side, too.
Dark side, you mean like dangers associated with it?
Yeah, phosphorus isn't just, like, reactive and flammable. It can be incredibly destructive. During World War II, it was actually used in incendiary bombs.
Incendiary bombs. So basically bombs designed to start huge fires.
Exactly. And these weren't your average fires either. These bombs were filled with white phosphorus, which burns so intensely that it's almost impossible to put out.
Okay, that sounds terrifying. I mean, regular fires are bad enough, but something that can't be extinguished easily, that's a nightmare.
It was a nightmare. The bombing of Dresden in 1945 is a prime example.
Yeah.
The use of phosphorus bombs there created a massive firestorm that caused incredible devastation.
I've read about Dresden. It was absolutely horrific. The fires raged for days, and the city was essentially reduced to rubble.
It was. And the thing about white phosphorus is that it burns so hot that it can even ignite things that are normally fire-resistant. There were reports of people trying to escape the fires by jumping into rivers, but the phosphorus stuck to them and continued to burn.
Wow, that's just horrifying. I mean, imagine being trapped in a firestorm and then jumping into water, only to have the flames follow you.
It's a truly chilling thought. And some historians believe that these horrific events, these images of inextinguishable fires, actually contributed to the cultural myths of hellfire.
Oh, wow, that's a fascinating connection. So, this element that can create both beautiful, glowing phenomena and incredibly destructive fires has also shaped our understanding of, like, the afterlife.
It really shows how the power of these elements extends beyond the physical world and into our beliefs and fears. But phosphorus isn't the only element with a dramatic side. Nitrogen, our other element of the day, has a whole different kind of explosive personality.
Explosive, you mean like phosphorus?
It's a different kind of explosion, not the burning kind. We're talking about massive detonations, the kind that can level entire city blocks. And the key player in these events is a nitrogen compound called ammonium nitrate.
Ammonium nitrate, that sounds familiar. Isn't that used in fertilizer?
It is. It's actually a really common fertilizer ingredient.
Yeah.
But what most people don't realize is that under certain conditions, ammonium nitrate can become incredibly explosive.
Okay, so something used to help plants grow can also cause massive explosions. That seems a bit counterintuitive.
It does, but it all comes down to the chemical structure of ammonium nitrate. It contains a lot of oxygen, and when it's heated or subjected to a shock, it can break down extremely rapidly, releasing all that oxygen in a huge burst of energy.
So it's like a sudden release of a ton of energy all at once. That's what causes the explosion.
Exactly. And the scale of these explosions can be absolutely devastating. Take the Texas City disaster in 1947. A ship carrying around 2,300 tons of ammonium nitrate caught fire in the port, and the resulting explosion was one of the worst industrial accidents in history.
2,300 tons. That's a huge amount. How bad was the damage?
It was catastrophic. The explosion completely leveled the port, killing almost 600 people and injuring thousands more. The force of the blast was so powerful that it was felt for miles around.
Wow, that's just unbelievable. I mean, it's hard to even fathom the scale of destruction from an explosion like that.
It's truly mind-boggling. And tragically, the Texas City disaster wasn't an isolated incident. In 2020, a similar event occurred in Beirut, Lebanon. A warehouse storing a massive amount of ammonium nitrate, estimated to be equivalent to around 1,000 tons of TNT, exploded, causing widespread devastation across the city.
I remember seeing the news reports about the Beirut explosion. The images were just heartbreaking. Entire neighborhoods were destroyed.
It was a truly horrific event, and it underscores the importance of understanding the potential dangers of ammonium nitrate, even though it's such a widely used chemical.
Definitely. I mean, knowing that something as seemingly harmless as fertilizer can have this kind of destructive power is a real wake-up call.
Absolutely. It's a reminder that we need to be aware of the potential risks associated with the chemicals we use and store, even those that we might think of as everyday and safe. But let's shift gears now from these city-leveling explosions to something a bit more mysterious, and dare I say spooky. Let's talk about ghost lights.
Ghost lights. Okay, we're going full paranormal now. You mean like those flickering lights that people see in swamps and graveyards?
Exactly. Those eerie lights have been a part of folklore and legend for centuries, known as Chirbati in India and will-o'-the-wisps in Europe. They've terrified and fascinated people for generations.
Yeah, I've heard all sorts of stories about them. Some people say they're the spirits of the dead, leading travelers astray. Others say they're just swamp gas.
Well, the swamp gas explanation isn't too far off, actually. While there's no evidence of ghostly spirits involved, there is a very real chemical phenomenon at play here. The culprit is a gas called phosphine.
Phosphine. Wait, is that related to phosphorus, the element we talked about earlier?
It is. Phosphine, or pH3, is a gas that's produced when organic matter decays in environments where there isn't much oxygen, like, at the bottom of a swamp or marsh. And here's the thing. Phosphine is flammable, and it can spontaneously ignite when it comes into contact with air.
Ugh. So those flickering lights people see aren't ghosts, but pockets of flammable gas igniting. That's both spooky and kind of cool at the same time.
It is. And it explains why these lights are often seen in swampy areas, where the conditions are just right for phosphine to form. But even though we know the science behind it, it's easy to see how people in the past, who didn't understand the chemistry, would attribute these lights to supernatural forces.
Absolutely. I mean, imagine wandering through a dark, foggy swamp and seeing these strange lights dancing around. It's like something out of a horror movie.
It definitely is. And those old folk tales often reflect the very real dangers of these environments. There are stories about travelers who followed these lights, thinking they were lanterns or torches held by other people, and ended up lost and drowning in the swamps.
So the lights themselves weren't necessarily dangerous, but the misinterpretation of them led to some tragic outcomes. It's a good reminder that even in the face of the unknown, it's important to try to understand the world around us.
Well said. But phosphine isn't the only chemical culprit behind mysterious fires. Back in the 1800s, coal miners were often terrified by spontaneous fires that would erupt deep underground. They attributed these fires to evil spirits or curses, not knowing that the real cause was a chemical reaction involving something called pyrophoric iron.
Pyrophoric iron, what's that? Another one of those elements I've never heard of.
It's not an element, actually. It's a form of iron sulfide, a compound that forms naturally in coal mines. And the key to its fire-starting abilities is its reactivity with air. When exposed to oxygen, it undergoes a process called oxidation, which releases heat.
So it heats up when it comes into contact with air. How does that start a fire?
Well, in the enclosed environment of a mine, where there's often limited oxygen, the heat from this oxidation reaction can build up without dissipating easily. Eventually, it can get hot enough to ignite the surrounding coal dust, or even the pyrophoric iron itself, causing a sudden and unexpected fire.
Wow, so these miners were literally working in a tinderbox, and they had no idea. It's no wonder they blame supernatural forces.
It is pretty wild, isn't it? But it shows how important scientific understanding is. Once we understand the chemistry at play, we can take steps to prevent these dangerous situations from happening.
Definitely. Knowledge is power, especially when it comes to dealing with potentially dangerous elements and compounds.
Absolutely. And speaking of powerful elements, we've talked about nitrogen's explosive side, but it has another trick up its sleeve that's equally mind-boggling: extreme cold. In its liquid form, nitrogen is so cold that it can instantly freeze things solid.
Liquid nitrogen. I've seen videos of people using it to like shatter roses and make ice cream instantly. It's crazy cold, right?
Crazy cold is an understatement. Liquid nitrogen has a temperature of -196 degrees Celsius. That's colder than the coldest naturally occurring temperatures on Earth.
Wow, that is ridiculously cold. So what happens when this super cold liquid nitrogen comes into contact with something like, say, water?
Get ready for this. It makes the water boil.
Boil. But you just said liquid nitrogen is super cold. How can something cold make water boil?
I know, it sounds crazy. But what happens is that when liquid nitrogen comes into contact with something warmer, like water, it rapidly turns from a liquid into a gas. This process is called vaporization, and it absorbs a ton of heat from the surroundings.
So the liquid nitrogen is basically sucking the heat out of the water so fast that it causes the water to boil.
Exactly. And because the nitrogen is vaporizing so rapidly, it creates a really cool visual effect. You see all this bubbling and steaming, and often a thick fog forms as the water vapor condenses in the cold air.
Okay, that's pretty wild. And it makes sense now that you explain it. But I bet people in the past who didn't understand what was happening were pretty freaked out by seeing water boiling on its own like that.
Oh, absolutely. You know, there are ancient accounts of people encountering natural pools of what we now know could have been liquid nitrogen in volcanic regions. They called them cursed lakes, or gateways to the underworld, because of their strange and seemingly unnatural behavior.
That's amazing. It really highlights how our understanding of the world has evolved thanks to science. What was once seen as magical or supernatural is now explained by chemistry and physics.
Exactly. So from water that burns to ghost lights to explosions that can level cities, and even water that boils without heat, we've seen how phosphorus and nitrogen have played some pretty incredible roles in shaping our world, our beliefs, and even our fears.
These elements, though seemingly ordinary, have been the source of both wonder and terror throughout history. And as we've learned today, understanding the science behind these phenomena not only helps us to appreciate their incredible power, but also reminds us of the importance of knowledge and critical thinking in navigating the world around us.
Couldn't have said it better myself. So for you listening out there, the next time you encounter something strange or seemingly magical, remember, there's often a fascinating scientific explanation waiting to be uncovered.
Keep asking questions, stay curious, and you never know what amazing discoveries you might make.
Exactly. And that's a wrap on our deep dive into the world of phosphorus and nitrogen. Thanks for joining us.
Thanks for having me.
Until next time, keep exploring and remember, the world is full of surprises, and often The most incredible things are right under our noses, just waiting to be discovered.
Absolutely. See you next time.